Hi guys, welcome to my channel. If this is your first time here, please make sure to click the red subscribe button below and click on the bell icon to get notifications for when I release a new video. This is part one of a two-part episode in which I discuss the form of factoring where the value of a is greater than 1. Please make sure you like, share, and subscribe because all this helps me create better content for you. So without further ado, let's get on to the video. Part one of fact where the value of a is greater than 1. Is this thing on? Hi guys, I'm a knowledge guy, AKG for short. And today we're gonna be talking about factoring with problems that look like this, problems that look like this, and problems that look like this. So stay tuned. Rules. Before we get started, there are a few things that I'd like to explain to you about factoring. Factoring is the art of breaking things down. There are many forms of factoring. GCF, grouping, quadratic formula. Well, that's not really a form of factoring, but it's literally separate from factoring, but that's besides the difference of square. It all depends on what type of problems we have that will determine what rules we use. Also, some make it easier than others. Factoring deals with parabolas, more on that later, and quadratic equations. Yeah, that's today. Equations can be difficult and or confusing to break. For equations, we showed it in the beginning. I want you guys to follow these steps for ultimate clarity. Step 1, form. You have to have the correct form in order for you to start to break down any equation. That's just a must. And if a problem is in incorrect form, then there's a remedy. That leads me to step 1A, the inverse. That will get your problem into the correct form that you need most of the times, which is to have a quadratic form. Quadratic form is ax squared plus bx plus c equaling 0. You have to have one side equal to 0. Step 2, factors. For most quadratic equations of the form that we saw in the beginning, you have to have factors of the extremes, both the a value and the c value. Then ultimately, you'll play around to get the middle value, but that's not what's important. So again, you have to have factors of the extremes, both the a and the c. Once you have those factors, then you can go on to step 3. Step 3, combinations. You have to form a series of combinations together in order for you to ultimately get the correct answer in the form that we're using. The form that we're going to be using for the first two problems, at least today, is known as guess and test. The pairs of factors that add up to the middle term ends up becoming the winners. From there, you're 90% done. Just set both equations equal to 0, solve for the actual roots, and voila, you have your answer. Let's use the steps we learned above to solve this problem. So let's get at it. The first step is form. This is not in correct form, right? Remember what we said when we initially talked about form. We have to get in the form ax squared plus bx plus c equaling 0. But this is not in that form. Right now, our c value is on the opposite side. So what we want to do is be able to move it to the other side. We can do that by using step 1a, the inverse. Again, like I said, the inverse does come in handy a lot of times. The inverse of the number that's at the end. The inverse of 2 would be -2. So I subtract 2 on both sides. Now, one side is 0. Perfect. Now I have it in perfect form. Now the equation reads 6x squared minus x minus 2 equaling 0. 1a. Now on to step 2. Step 2 calls for the factors. Our factors are listed below. We need to find numbers that multiply up to 6 and also multiply up to -2. Now we have to play around to get the perfect combination, which leads us to step 3, combinations. We're gonna play around with it to see what combination gives us our middle value. That's what we're gonna do right now. So if you look on screen and to my left, you're gonna see a whole set of combinations that I have laid out. And when we multiply these sets of combinations, as you can see, only one combination set actually works out to make the middle terms the negative. And that combination is 3x minus 2 times 2x plus 1. When you multiply it together, you get a middle value of -x. So that's our factor. Now what we have to do is solve for x. We need to get our 0 values. So what that means is that we have to go on to step 4. I didn't explain about step 4 in the beginning, but here it is. Step 4 tells us just get our roots. Set it equal to 0, and we solve for x using the inverse. Using that method, as you can see, you can find that our values are x equals 2 over 3 and x equals negative 1 over 2. That's the first one. Press that like button and subscribe right now.